Okay, I want to get back to where I have all of the easy problems done. At least all the ones that I can see. I don't have premium, so. Okay, make array elements equal to 0. You're given an integer array nums. Start by selecting a starting position cur such that nums of cur equals 0. Okay. And to choose a movement direction of either left or right. After that, you repeat the following process. If cur is out of range, this process ends. Okay. If nums of cur is 0, then move in the current direction by incrementing cur if you're currently moving right, decrementing cur if you're moving left. If it's greater than, then reverse your direction. Take a step in the other direction. A selection of the initial position cur and movement direction is considered valid if every element in nums becomes 0 by the end of the process. Return the number of possible valid selections. Honestly, that doesn't seem like an easy, but you know what? Maybe these numbers are small enough that it is. So boom, 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 boom. Okay, and move to the right. So once a 0 has been converted, then we stop. All right, right, left. Start by selecting a starting position cur such that nums of cur equals 0. Okay, so we have to start from zeros. And then we either go right or left. I think we can remove the zeros as we go. That makes sense to me. Is this brute forceable? Is that like an n to the 4th or something? Well, if there's two values that are non-zero, then it's going to sit there and alternate between the two of them. We don't have to run that as a simulation. So, yeah. So, valid starting positions. And what does it repeat? What does it return? Cur 3 and a movement direction to the left. Cur 3 and a movement direction to the right. So every valid starting position, we'll call that SP, is like this. So for I in range nums, range length nums. Okay, if nums I equals 0, then this is a valid starting position. So sp.append -1. Well, let's put the position first. So you can either go right or you can go left. Yeah, I'm just trying to think if it's alternating. I don't think brute forcing this without removing the zeros is feasible. But we do need all of the initial starting positions. So works equals 0, I guess. Okay, and then for position direction in SP, if I have no idea, PD if r of p comma d comma nums then works plus equals 1. Yeah. Okay, so I feel like the first thing that we should do is prepare it by removing all of the zeros. So we need to know the count of the zeros to the left and the count of the zeros to the right, and we know that it is a 0 to begin with. So it's going to automatically advance. Okay, sorry for leaving the desk. All right. It's almost like we need to know a number of counts of zeros. So let's say counts, and is that going to include itself? Well, it doesn't matter because we're moving off from the very beginning. So times length of nums, and then we'll say yeah, counts of I plus equals 1 in this case. And then counts of I equals counts of I minus 1 if I is not 0. So like that. And then this will increment it, and then that will tell us how many, how many zeros there are to the right and to the left. Now, we're going to need a filtered version of nums that's going to get rid of this. So we're going to say nums of, no, well, we'll say n2 equals I for I in nums if I. And then we need to adjust it so that we're actually looking at the correct thing now. So I feel like it, because it's going to be the position that it lands on after it's moved, right? So yeah, well, I mean, let's just it's almost like I need to see the numbers. Okay. Okay, so let's do the edge case. It is index 0, the count is 1, and you're moving to the left. Well, then it really should be -1 because you're gonna be off of it. So the adjusted position is going to be the position minus counts of the position plus the direction, right? Yeah, and if you were going to the right from position 0, then you would correctly get rid of position 0. Which is fine. So that would make you -1, but it would move you to the new position 0 by adding the D, and that new position 0 is going to be index 0. So that sounds right to me. And then this is going to be N2. I'm still worried that this is going to be like too slow. Now it's gonna bounce like a pong ball back and forth. There's probably a better way to calculate this, but I can't see it. So we don't want to modify this list unless we're working off a copy. I'm going to say n2.copy, I guess. That'll allow us to modified list. So now, if P, well, first off, if Li is empty, then everything is good. Okay. If it's not empty, if P is greater than the length of Li, then return sum of Li equals 0. Okay, and this is going to be or P is less than length of Li. All right. Otherwise, now we are operating off a copy, so that's fine. Yeah. Now, if Li of P equals 0, then two things we need to say. Li dot pop. Can we do that? Yes, we can. Li dot pop P. And how does that affect it? Let's see, if it was going to the left and we popped P, then it's still going to the left, so it's fine. If it was going to the right and we popped P, then it's still going to the right, so it's fine. So return we're done with this, so I don't think we need to copy it in this case. No, because there could be multiple. Yeah, let's always copy it. Let's always copy it. That's just safer. All right. Okay, now it will change directions. All right. So it's going to bounce back and forth between two non-zero values, right? So I'm just having trouble visualizing. If d equals -1 and Li of P is greater than 0 and P plus 1 is less than length of Li and P plus 1 is less than length of Li. D equals 0 and Li of P is greater than 0 and P plus 1 is length and less of Li. And Li of P plus 1 is greater than 0. Then it's going to bounce back and forth between the two until one of them is exhausted. So if they're both 1, it will return to its initial state, but they'll both be decremented by 1. That sounds correct to me. So min value equals min of Li of P and Li of P plus 1. See, this doesn't seem like an easy problem to me. This seems significantly more difficult than easy, but yeah, okay. So Li of P, and then it's just going to be Li of P minus equals Mi of V, and Li of P plus 1 the same. And then Okay, so if it was 1, it'll bounce and be going the same way. If it's 2, then it'll boom, boom, boom. No, it seems like it always ends up going the same direction. You know what? Therein might be the... yeah. Now we have done something with this, and we need to start over again. So R... wait, one of these is going to be 0. No, it was going to the left. I suppose it matters which one is 0. If Li of P equals 0, then Li.pop P plus 1. Yeah, and then if Li of P equals 0, then Li.pop P. And that leaves it going the same direction, right? Do we need to adjust it? No, because the only thing that it could possibly do is move it down. Yeah, we do need to move it off. So return, because imagine you got rid of a 1 and a 2, and you were on 1. Then the next one that you need to look at is 0. So it's going to be P plus D, or just P minus 1, whatever. D, comma, Li dot copy. Now we have to mirror this ridiculous thing right here. If D equals 1 and Li of P is greater than 0 and P minus 1 is greater than or equal to 0 and Li of P minus 1 is greater than 0, this becomes minus 1. This becomes minus 1. This becomes minus 1. This becomes minus 1. This has to go here. Okay, now consider the case that you had been traveling right, but you're bouncing off the position 1, and you went back to 0, and then you got rid of both of them, right? Yeah. If there is the slightest possibility that something to your left was deleted, then we need to take that into consideration. So adjustment minus equals 1. Adjustment minus equals 1. So what we're going to have is we're going to have P plus 1 minus adjustment. So let's say we had originally been at 1. We were going to go to 2. If nothing is removed and we're done bouncing, then we would go to... Of course, that would never happen because one of them is always going to be exhausted. But, okay, let's say that the one on the right is exhausted. So it's bouncing between 1 and 2. And so you eliminated one of them. That's going to be an even number of times, so you're still going to be going the same direction, right? So you want to go to the right, but it's going to be offset, and you're going to be back where you started from, but you've gotten rid of a number. So yeah, that is correct. Okay. I don't think there's any case where we can have a 0. All right. So now if Li of P equals 0, then we continue in the same direction, right? Then, did I do that already? If Li of P equals, yes, we did. So we know that we are hitting a value. I don't see how it could be anything other than these two cases. Well, it could if there's some other 0 somehow that we didn't account for. Just whatever. If, then, and it will change direction, right? So Li of P minus equals 1. If Li of P equals 0, then Li dot pop P and return R. Where's R? R of P comma D Li dot copy. So we know that it wasn't originally 0, but this could make it 0. If it's not 0, then we don't pop it, and we return P plus D, comma, D times -1. And we have to copy it because we're sitting there modifying the array. So, yeah. List index out of range. Line 17. If Li... Okay, none is not a valid type for the expected return type integer. Okay, so it did terminate then. All right. Let's see if we can implement just the naive case and then optimize it from there. This is clearly not working. Okay, so this is the naive case. There's no way that this won't time out, but you know, at the very least, if not Li, then return true. If P is greater than that, return sum of Li. Li of P there has to be a continuon. If Li of P equals 0, then Li dot pop of P. Okay, let's see if the naive solution works in cases where it does not time out. It does not. Interesting. Print P comma D comma Li. One negative 1 1 1. Okay, where's the decrement? Where is? I see no decrementing happening. 0, 1, 2. This should not be 3. Something is wrong here. These initial values are miscalculated. I wonder if my original code worked and this nonsense didn't. So print counts. Okay, so the counts were 0, 1, 1, 2, 2. Okay, so it started here, and it should have subtracted a 1. Then it added the D back. Maybe you don't add the D. Maybe that was a mistake. PD. Show me SP. Yeah, well, we know that counts of 1 is 1, so why isn't it subtracting? Oh, for hell's sake. All right. Okay, 0, -1, 0, 1. It doesn't even seem like it's recursing at all. Okay. If not li, then return true. If p is greater than length of li, or p is... What in the... Well, I figured out why it wasn't recursing. Why didn't somebody tell me I did that? Okay, so it got rid of the 1, but it didn't change direction. Interesting. Could be a simple bug here. If li is 0, I need to be able to see where the... Doesn't seem like it's changing direction. If it equals 0 after you subtracted it, then it still has to switch direction. If it's 0 before, then you don't switch direction. That looks more like it's actually doing something. Okay, so 0, -1. What am I looking at here? Oh yeah, it kills that and then it switches direction, which is exactly what it's supposed to do. So 0, 1. So it's trying to go right, but it decrements instead. So then 1, -1. No. No, 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 no. Hey, look, it's right. Okay, let's get rid of these prints here. There's no way this isn't going to time out. I mean, it's just... Okay. So all the prints should be gone. Maybe this isn't as computationally difficult as I thought. Well, it would appear that I have failed. Because it's not timing out. It's just my naive solution is not working. If it is 0, then we don't advance it. I don't think this is correct. Because if it was going to the left... Here, let's use this test case. Okay, if Li of p equals 0 and... d equals -1. If it's -1, then we need to subtract 1. We can stay where we're at if it's +1. Now I wish that I hadn't deleted all of that. You know what? This is... I'm probably making it more complicated than I needed to. Prefix sum. If the total left sum is close to the total right sum, what does close mean? They're saying if the amount to the left is the same as the amount to the right. All right. Well, that actually does make sense. So if they're identical, all right. Okay, so left sum equals list of accumulate of nums, right? And then right sum equals reversed list of accumulate of reversed nums. Hey, you know what? You know what? Even if I failed, I feel like I learned something. Because, yeah, it something was clicking in my head when it's like going back and forth, but the position is never changing. Yeah. Okay, so for I in range length nums, we're going to say, okay, we'll have a counter. So if nums of I is 0, then if left sum equals right sum of I, then c plus equals 2. Else, if the absolute value of left sum I minus right sum I equals 1, then c plus equals 1, return c. And that would be an order n solution, and everybody's happy. Object is not subscriptable. Might be an extra list in there, but whatever. For an order n efficiency, it's not like it really matters. Okay. Well, I'm not going to post that solution because I didn't actually do it on my own. But you know what? It makes sense intuitively, so learning is probably more important. All right, see ya.